Okay, so it's now 11 hours. I think we can start. Yes. Okay, good morning everybody and welcome to our first Orange Cyberdefense Attache security webinar for this year. My name is Edwin Rombeek and I'm responsible for the new business team within Orange Cyberdefense. Together with my colleague Peter van der Voort, our solution architect for OT, we have a focus on this area. So what can you expect during this webinar? Peter will dive deeper into the risks and questions that exist in the many organizations are the bad guys already in. So if there are any questions during this presentation, you can ask them on the GoToWebinar sidebar, and we will answer them at the end of the presentation. And of course, this session will also be recorded. So Peter, the floor is yours.
Thank you, Edwin. Thank you very much. Good morning, everyone. Nice to see you all here. And let me briefly introduce myself. I am Peter van der Voort, and at Orange Cyberdefense, I'm a solution architect for the OT domain. This means that I have quite a technical background, and what I do is I help organizations to move forward if they want to adopt Industry 4.0. And I realize that Industry 4.0 is a bit of a buzzword. It's like an umbrella term. But in many cases, it's about increasing the efficiency of operational processes or optimizing production, move data to the cloud for analyzing or even building digital twins. In any case, everything that can be captured by the word Industry 4.0, I help organizations to do this in a cyber secure way, mainly by providing advice about technology or about processes, or even by implementing technical solutions. With that being said, in the next half an hour or so, I'm going to say something about the subjects on the screen here. And I'm going to start with some basics, just to provide an understanding of the situation in the OT domain, or at least a possible situation. And then I will briefly touch on the subject of threats. I will talk about something that is called security through obscurity. And for those who don't know, this is security based on the fact that something can't be seen, or at least is hidden somehow. And I will explain why I think this is not a good strategy. Further, to understand the risk from a cybersecurity perspective, I think it's important to know why industrial control systems are being targeted and who is doing it. And then we go to the main subject, because if you want to answer the question whether the bad guys are already in, you need a way to detect them, right? And we'll conclude this session with just a little bit of information about Orange Cyberdefense, and I promise to keep that very short, and then we'll go on to the Q&A. If you don't mind, I'm going to switch off my camera during the presentation to avoid distraction, yeah, let's get started. So, in the beginning, there were only like operational systems, and the internet didn't even exist. Hence, it was easy to maintain an air gap because there was nothing to connect to anyway. So at that point in time, an air gap probably did exist. At another point in time, however, office automation was developed and even something like the internet. And many companies tried to maintain the air gap to remain secure, to remain protected from external threats. And it was a sort like security through obscurity, meaning that if external actors can't see it, it will be safe. However, history has shown that it doesn't work like that. And probably the most known example is Stuxnet, which invaded a nuclear facility in Iran, while that network was completely isolated. After investigation, it was found that the malware entered the network via a USB stick, and that was placed by an infiltrator, or at least that's what they say. And there is another way in which an air gap doesn't work. Because what if you use software inside the OT domain, let's say software to monitor the availability of network equipment. And then you receive an update for that software. And it turns out that the update is compromised and contains malware. And this is what happened last year with the SolarWinds monitoring software. And this attack is really an interesting one. I don't know if you've heard about it. This is what they call a supply chain attack, because an organization is not attacked directly, but another company somewhere in the supply chain is attacked, and in this case, compromised. And for those who don't know, SolarWinds is a monitoring platform to monitor your IT assets or even your OT assets. And you can imagine that such a monitoring system needs access to each device in your network, right? Otherwise, it's going to be quite hard to do monitoring. And on top of that, some companies use SolarWinds to actually configure network devices. Now, what happened was that attackers compromised SolarWinds, as in the company itself, not just the product. So they hacked the company, they found the source code of the SolarWinds platform and added code of their own. And this code obviously provided a backdoor for the attackers. So as users of the platform updated their software, through regular software updates, they also included the backdoor for the attackers. And in this way, the attackers didn't have to go through the trouble of hacking many companies. They just hacked a vendor in the supply chain. And this picture shows how persistent the attackers must have been, because the attack started probably before October 2019, because the first modified version of the software that could be tracked was from October 2019. So therefore, the hack must have taken place somewhere before that. And they first made small changes to the code just to see if it would end up in the updates. And when it did, they started buying domains for their command and control infrastructure. And then a real compromised version of the software was found in March 2020, but it remained quiet for a couple of weeks. And then only in April 2020, there were indications in DNS that there was communication between the victim and the attackers. Now, with this in mind, you can see that the supply chain represents a significant risk to ICS systems, because ICS manufacturers and software developers, they create their products in many different locations around the world. But to ensure the security of the system or application throughout its development lifecycle is really impossible for most ICS operators. So purchasing commercial off-the-shelf technologies really increases the likelihood of receiving non-genuine equipment. And also there are reports related to equipment with embedded unauthorized code in its firmware or operating system that provides a backdoor into the equipment or allows a program to call home once installed. And of particular concern with regard to the supply chain risk is the information regarding the operation of sensitive hardware and software that vendors generally provide on their websites. Because the bad guys can easily find default passwords, operational instructions, vendor manuals, information provided by users of the software and hardware, and it's right there on the internet, in white papers, blogs, social media, and so forth. So adversaries armed with this information are well equipped to compromise these systems. Now, this SolarWinds hack is one of the latest big hacks that became public, but let's have a look at what happened in the past as well. Now, over the past couple of years, there have been quite a few attacks, and what is shown here are only the well-known or the publicly available attacks. It's most likely that there are many, many more, but many companies also don't want the publicity, and so we don't hear about it. But based on this and what we see here, we can actually draw an interesting conclusion, because some of these attacks explicitly target ICS systems. For example, Stuxnet that I've mentioned before, Havex and Black Energy. But other attacks are not explicitly targeting industrial control systems. And we'll look at WannaCry. Probably everyone can remember that one. And WannaCry is ransomware, and it encrypts data in the IT environment. The thing is, though, that it directly impacts the OT domain. Because you can imagine that if, for example, packing slips or labels are printed in the IT environment and this capability is impacted, a company won't be able to send or transport its products. So you may as well shut down your production facility, you know, if you can't ship your goods anyway. And that is probably where the greatest threat is coming from. You know, today it's not per se that adversaries gain access to the OT domain and start doing bad things. Instead, many issues in the OT domain are caused by issues in the IT domain, which makes sense because the attack surface is much bigger. It's much easier to actually attack an employee or his laptop in the IT domain than it is to target something in the OT domain. And in this way, although the OT domain isn't a specific target, it's impacted anyway. And the bad guys, they are increasingly starting to realize that there is money to make in that area. And I will talk a bit more about that later. Now, before we dive a bit more into why someone would attack industrial control systems, let's have a quick look at the concept of security through obscurity that I've mentioned before. Which basically means that companies think they are secure and that their systems aren't at risk because they believe their systems aren't visible to the outside world. And obviously that may very well be the case, and then I would have to agree that it may be safe and secure. However, this is a search engine, it's called Shodan, which is designed to find operational systems. And when I say operational systems, I'm talking about that really in the broadest sense of the word, whether it's power plants, refrigerators, or webcams, or any other device which we nowadays call Internet of Things. If it has an IP address and if it is somehow connected and accessible, it will be found by the crawlers of Shodan. And Shodan is really the search engine for the Internet of Things, for connected devices. But it doesn't just find these devices, it also tries to log in using default credentials that usually go with such devices. And this site is accessible for everyone. Just create a free account and you can start searching this Shodan database. Now, what I've done here in the search box, I have searched for country, the Netherlands, and then I've entered the keyword Siemens. And why Siemens? Well, just because they are a manufacturer of PLCs. And I wondered if any of their equipment would be online. You know, I could have entered any other PLC vendor or equipment vendor, or even a search string. For example, you could enter the term infusion pump, because a while ago there were quite a few of those online for some reason and could be accessed with default credentials. So can you imagine being in the hospital relying on an infusion pump that turns out to be accessible from the internet, right? Anyway, in this case, I'm using Siemens as an example, and I get really several results. Now, when clicking on one, I get this login screen. Now, that's weird in itself, isn't it? A login screen to a Siemens device right there on the internet. But it gets even stranger. Do you see the text below the input boxes? Well, this says that this web server allows for remote plant control. So a web server for remote plant control accessible from the internet. How strange is that? And this message even says that operator interventions change the situation on the plant. Now, I truly hope that anyone in this webinar don't recognize this device as one of your own, or otherwise maybe good that you're aware of it now. But I guess it doesn't need further explanation. And fair enough, this is still protected with the username and password. So it's not like I can immediately go ahead and change plant operation. But sure enough, if an attacker would combine this with some more investigation, find out which company this is based on the IP address, search LinkedIn for employees, and then possibly use some social engineering, I would say that there are chances that at some stage he will get in, or perhaps just a brute force attack would do as well. Now, based on this, I think we can draw the conclusion that real security is a must-have. So we can't go by security through obscurity, and we can't take the chance that nothing will happen, because it really is a matter of time before your systems are being found and someone will attack it if it's connected somehow. So with this in mind, you could still ask yourself, why someone would possibly want to attack an industrial control system, right? So let's have a look at that. So the first reason to mention is hacking for fun and profit, as they say. And what we mean by this is ethical hacking. So people trying to find vulnerabilities and having fun doing so. And if they find something, they notify the owner of the system, and hopefully they get some sort of bonus and make some profit. Next one, script kiddies. These are people who actually have no idea what they're doing, but they have found some hacking tools online and are just using these tools to see what happens. And by doing so, they can obviously create small or even big disasters. Then collateral damage. It does happen that someone in an organization just clicks on the wrong link or open an attachment that he shouldn't have. And even if that organization wasn't actively being targeted, the malware will be inside them. And especially with automated malware, because attackers are just looking to find as many victims as possible. So they basically don't care who you are. Criminals are the next to mention, and this makes sense, right? All they have in mind is to earn really as much of money as possible. And they can do so, for example, by disrupting operations. And they don't care what needs to be done, they just do it. And what I've mentioned before, if they attack the IT domain, because the attack surface is much bigger, they can also disrupt operations. On the other hand, I think it is widely known that cybersecurity in the OT domain is not at the level it should be. So the bad guys know that as well, obviously. And therefore, they are looking for ways to directly attack the OT domain. And what we've seen lately is what we call double extortion. Because in some cases where an organization didn't want to pay to get rid of ransomware, for example, the attackers threatened to expose confidential information. So in the past, ransomware just encrypted information and nobody could use it, and that's it. But nowadays, the bad guys actually steal the information, they encrypt your copy of the data, and if you decide to not pay and restore data from a backup, the attacker will expose your data to the public. So that's really being caught between a rock and a hard place, right? So what can arguably be worse than a criminal is probably a nation state. Those will most likely be after, I know, nuclear installations and things like that, like Stuxnet. But they're also after security companies like FireEye, which came to light in December 2020. Probably operators of critical infrastructures would also be potential targets, but also companies with specific intellectual property like chip designs or some form of research data. I'm sure that countries like China or countries maybe in the Middle East would be interested in this. So these are some of the reasons people would be after industrial control systems. So with all previous in mind, knowing what the risks are and knowing that your organization may possibly at risk, how can you be sure that the bad guys aren't already in, that there isn't any malware on your industrial network? Now, I have to say that in some cases, it can be very hard to detect, especially when the attackers are very sophisticated, like the nation state hackers I just mentioned. However, in general, it can be very well detected. There are only two real requirements. The first is that you must be looking for it. If you don't look, you don't see. And the second requirement is that you need to know what to look for. So let me give you some pointers as to what to look for and how to do that. And what I'm going to say is based on the reference model shown here. And this is called the Purdue model for ICS. And for those who haven't seen this before, let me quickly explain. Here at level 0, there are the actuators, like pumps, motors, fans, and things like that. At level 1, there are, for example, the PLCs, which control the devices in level 0. At level 2, there will be SCADA systems, which can also sometimes be found at level 3, together with HMIs. Level 4.5 is the IT domain, and level 3.5 is basically the bridge, the demilitarized zone between IT and OT. And as you can see at the right side of this picture, it is possible to position firewalls in between these layers to provide security and visibility. Okay, so let's get back to detecting bad guys. Let me start with an easy one, failed logins. This is always a sign that someone malicious is trying to do things that he shouldn't do. And by this, I don't mean someone who enters a wrong password once or twice. No, I'm talking about dozens of failed logins. In most cases, if a login fails, a syslog message is being sent. So you need to be on the lookout for these types of syslog messages. And that basically means that you need to set up a syslog server, obviously, and where these types of messages are captured. And then you need some form of automation, because you can imagine that if there are like thousands of messages a day, not only about failed logins, but also about other events, it's going to be quite hard to manually dig through and find what you're looking for. So you need some form of a scene or even a small script to group these messages. What is important though is to capture this information from as many devices as possible, including devices on level 1 and 2. The second indication of malware in your environment are port scans. Malware or an attacker will try to extend the footprint in the network and therefore look for other vulnerable systems. And in some cases, this can really be difficult to detect, I know, because if malware is looking for only 1 or 2 specific ports to be open, it's not really a scan of all ports. However, such a scan often does query all IP addresses in a certain range. So if you see the same port being probed on, I don't know, 100 IP addresses, that is an indication that something is not right. On the other hand, detecting a port scan can also be difficult if the attacker really takes it slowly. You know, if the attacker probes like 1 port a day, it's going to be hard to detect, even if you have an intrusion detection system deployed, which is in general the device to use for detecting port scans. But there is another option here. What you could do is deploy a decoy. You could set up a server that no one should ever communicate with. And this means that if traffic is received by the server, you have reason to be alert and to investigate. And for now, I just want to mention this as a possibility. I won't go too deep into it, but in a couple of weeks, on the 16th of February to be exact, I'm doing another webinar as part of this series of webinars. And that webinar goes into some basic tactics, some basic security measures that you can do yourself to defend the OT domain from cyber threats. And there I will talk a bit more about setting up a decoy. At the end of this presentation, I'll show you the link where you can find more information and register if you're interested in attending. Next up, traffic patterns. For this, you do actually need something like an intrusion detection system, or at least that functionality. Whether on a separate appliance or as part of a next-gen firewall, if traffic is monitored, it is possible to create a baseline of normal patterns. And that means that if there is a deviation from that baseline, something may be wrong. So by placing firewalls between the several layers as shown here, it will be possible to monitor traffic and to get this baseline. And obviously this will not show traffic inside a specific level, but at least there will be some visibility now between levels. The next two values of variables and unexpected writes. Well, this is more about deep packet inspection. As you may know, many operational protocols like Profinet and Modbus, they're not encrypted. So it's possible to capture this traffic and look at the actual data that is being sent to, for example, a PLC. And it is possible to see which values certain variables get. And if you see that the speed of a motor is always 1000 RPM, or there is a set limit between 900 and 1100 RPM, and then some variable is changed saying that the motor should run at 2000 RPM, something may be wrong and there could be a need for further investigation. And the same goes for unexpected writes. If a PLC is reprogrammed, that would be visible in the network traffic. And obviously, if it's a scheduled change, everything's fine. But when it's an unexpected write, again, something may be wrong and investigation would be required. And the last one to mention is horizontal traffic monitoring. This one is a bit in line with the port scans. If an attacker tries to gain a bigger footprint inside the network, he will really be looking inside the network and not so much connect to the outside world. Now, detection of this kind of traffic would require a firewall, for example, in the lower layers of this model, and then it would even be possible to block the traffic and alert on it. However, it would also be possible to passively just listen to traffic, just monitoring it and visualize communication. And this would be more reactive as compared to the firewall, which can block traffic immediately. But if you want to make sure that there is no chance whatsoever that the operational process is disturbed, passive monitoring is the way to go. So these are 6 ways or 6 possibilities to detect whether the bad guys are already in. Some are quite easy to do, others require a bit more effort. But if you would be looking at implementing one or more of these solutions, just know that it is quite easy to actually combine these possibilities into one single solution. So there's no need to buy all kind of separate solutions and implement those. Now, unfortunately, I don't have time now to dive into that, but feel free to contact me after this webinar. I will show my contact details later. If I can provide any additional information about these measures and how to implement them, just reach out and let me know. So we are getting to the end of this webinar, and I really hope that you've learned something new or gained some insight that you can use in your specific situation or at your company. And to close this off, please allow me like 30 seconds for a shameless pitch about Orange Cyberdefense. Over the past 12 years, we are already known to be a leader when it comes to cybersecurity in the IT domain. And by utilizing this knowledge and knowing that a lot of attacks on OT are based on IT cyber attacks, and we are very well positioned to help organizations to secure industrial control systems from cyber threats. And we don't provide cybersecurity for the sake of cybersecurity, but by doing this, we actually help organizations to move forward on their goals, as mentioned before, which nowadays are often summarized as Industry 4.0. And it often involves optimizing operations or working more efficient, saving cost and things like that. And to help organizations, we have built a demo center in which we can actually reproduce parts of real industrial systems, and we can test software upgrades or patches, and we can provide training, and we can actually reproduce attacks to learn how to protect against them. Well, there are a lot of more things that we can do to support you in this domain. So if you have additional questions or run into issues, just know that we will be able to support. With that, we've come to the end of this webinar. As mentioned, this was the first in the series, and the next one is scheduled for February 16th at 11, as you can see here. You can register via the link shown if you think this may be of interest. Yeah, but since I'm doing this webinar, I can already tell you that it's going to be a very interesting. So at this point in time, let me have a quick look at if there are any questions. 1 second. I will turn on my webcam again so that you can see me again. Okay, so there is one question asking, you mentioned monitoring in the lower levels. Is this really passive? Yes, that is really passive. So what you do is basically you capture the traffic from a span port of the switch that doesn't interfere with the operations. So it's really passive, and in that way it's being monitored. Okay, so there is another question, and it says, in which way can you get insight in your assets active in the OT domain? Oh, well, basically that is in the same way, basically, because when you monitor the traffic, you can see which IP address is talking to which other IP address. So then at least you already know the traffic flows. But since most operational protocols are not encrypted anyway, and they are quite chatty, they will also tell you what device there are, what software version they're running, and things like that. So it's quite easy to get an inventory of all your assets in the OT domain, and that includes I know, PLCs, HMIs, Windows systems, things like that. Okay, so these were the questions that I can see. Okay, so if there are no more questions, you will receive this recording or a link to this recording for later review. But also my email is on the screen, and if you need any support, just don't hesitate to get in contact with me. Okay, so I don't receive any additional questions. So with this, we're going to close the webinar. Thank you very much for attending, and for now, have a great day. Thank you very much. Bye-bye.